Hi, I'm Allie Sealander with UTD GeoNews, and I'd like to tell you about an exciting new animation that shows some of the big changes that the Earth has gone through over the last billion years. The plates that make up Earth's surface are constantly moving. Plate tectonics is unique to Earth, and geoscientists are figuring out how far back in time we can reconstruct the bumps and splits and disappearances of Earth's tectonic plates. In a recent paper in Earth Science Reviews, Andrew Meredith and co-authors reconstruct the dance of the plates over the last billion years. There are lots of uncertainties in all plate reconstructions, and the farther back in time the animation goes, the larger these uncertainties become. You can learn all about the author's methods and uncertainties by reading this paper. In this video, we're going to show and explain their reconstruction. We will first show you the animation of the plate tectonic reconstruction in reverse, moving from the present into the distant past. Then we'll move forward in time from a billion years ago to today. Along the way, we will stop to label different continental fragments at 500 million year intervals and briefly explain some of the most important tectonic events. Also, please note that the Mercator projection used in this animation will exaggerate things, increasing the size of continents as they get close to the North and South poles. Let's get started. Here we are today. Colored areas are continents and white areas are oceans. The boundaries between the tectonic plates are colored. Red lines with barbs are convergent plate boundaries, where one plate sinks beneath another. The barbs are on the overriding plate. Blue lines are either divergent or transform plate boundaries, where two plates move apart, like at the Mid-Atlantic Ridge, or slide by each other, like along the San Andreas Fault of California. The brown areas are continental blocks that formed before 1 billion years ago, called cratons. Some of these cratons are only labeled by their initials. The paper will explain these abbreviations. Blue areas represent new continental crust that formed sometime in the last 1 billion years. The time of the reconstruction is given at the top. MA is short for millions of years ago. Got it? Okay, let's step back in time, in million-year intervals, stopping briefly at 500 million years to catch our breath. Then at 1,000 million years, or a billion years, before we run the animation forward to the present. Here we go. 1 billion years ago, things looked very different than they do today. The North American continental nucleus, Laurentia, labeled L here, is not flanked by the Pacific and Atlantic Oceans. Instead, it is the middle of a supercontinent called Rodinia and rotated 90 degrees clockwise, relative to its present-day position. So Canada is on the right, and southern USA is on the left. Fragments of what are today China, Australia, and Antarctica are attached to Laurentia's north, adjacent to the present-day west coast of North America, and fragments of modern South America and Europe to its south, adjacent to the present-day east coast of North America. Over the next 500 million years or so, Rodinia broke up and its fragments dispersed. This was the Neoproterozoic era. The Neoproterozoic era was a time of incredible changes in climate and life. This was when the Earth almost froze over during several episodes of Snowball Earth, and when complex multicellular life came into being. At the end of the Neoproterozoic era and the beginning of the Phanerozoic era, a new supercontinent formed, called Pannotia, or Greater Gondwana Land. Nearly all of the continents were combined at this time, with the Great Ocean, Panthalassa to the north. Greater Gondwanaland broke up all through Paleozoic time, sending fragments north into Panthalassa, where they recombined to make a northern supercontinent known as Laurussia, a combination of Laurentia and Europe. By about 310 million years ago, Gondwana and Laurussia collided to make a new supercontinent, Pangaea. The Pacific Ocean had formed, and a broad seaway called Tethys extended west from the Pacific. The next supercontinent, Asia, would begin to take shape on the north side of Tethys, largely composed of fragments that drifted north from shrinking Gondwana. One of the most important events of the past 200 million years was the opening of the Atlantic Ocean. This happened in 3 steps. First, the Central Atlantic opened between North America and Gondwana, beginning about 180 million years ago. Next, the South Atlantic opened within Gondwana, beginning about 110 million years ago, forming the separate continents of South America and Africa. Finally, the North Atlantic opened between North America and Europe. Another big event that happened beginning about 50 million years ago was collision between India, a fragment of Gondwana, and the rapidly growing supercontinent of Asia. 2 other Gondwana fragments, Arabia and Australia, will be added to Asia soon. We hope you enjoyed and learned from this animation. Thanks for watching. I'm Allie Sealander with UTD Geo News, and I'll see you next time.